moles of potassium hydroxide and 1 mole of copper 2 sulfate to produce 1 mole of copper 2 hydroxide and 1 mole of potassium sulfate. To understand this lab, one must understand the concept of stoichiometry, which is the relationship between quantitative substances that take part in a reaction forming a compound with ratios of whole number integers. Furthermore, stoichiometry follows the law of conservation of mass, which states matter cannot be created nor destroyed in a chemical reaction.
In a chemical reaction, there is always a limiting reactant, which is the reactant that is completely consumed in a reaction. Let's say we need 2 buns and 1 patty to create 1 hamburger. If you have 8 buns and 3 patties, the limiting reactant would be the patties because it is the reactant that controls how many hamburgers can be created. We can create 3 hamburgers and we have 2 buns left over, which is the leftover reactant.
To start our lab, we had 8 test tubes, 2 waste beakers, 2 burettes, 1 burette stand, 2 funnels, 1 ruler, 1 stir rod, 1 bottle of distilled water, a clamp, goggles, copper sulfate, and potassium hydroxide. We discerned that the potassium hydroxide was clear and cold, while the copper 2 sulfate was cold, light blue, and had no scent. Furthermore, we cleaned out the test tubes, beakers, and burettes with distilled water that was filtered. To start the lab, we dispensed 5 milliliters of copper 2 sulfate in each of the test tubes. Then we added 1 milliliter of potassium hydroxide into test tubes 1, 2 in test tubes 2, then followed the pattern up to the 3rd test tube. Then we added distilled water into each test tube in order for all of them to have a 13 milliliter solution. As we let the solution settle for 15 minutes, we observed the precipitate and supernatant form. A precipitate is a solid substance formed in a substance during a chemical reaction. A supernatant is a liquid lying above a solid precipitate after a chemical reaction.
We found that the products in test tubes 1 through 6 were a light color, while 7 and 8 had a dark precipitate. We measured the heights of the precipitates using a ruler and noticed that the heights of test tubes 1 through 4 gradually increased while 5 through 8 started to level off. In the first 4 test tubes, the limiting reactant was KOH because as you added more increasing amounts, you were able to produce an increasing amount of PBT. The KOH limited or controlled the amount of precipitate produced. However, it was shown in test tubes 5 through 8 the heights of the precipitates leveled off while CuSO4 stayed about the same. This means that CuSO4 controls the amount of precipitate produced. In contrast, the KOH kept increasing and the amount of precipitate was not affected. In our lab, we may have added too much or too little of the reactants into our solution, causing inaccurate results.
To better our results, we should be more precise with measuring our reactants, and this would in turn lead to better outcome.